let's take a look at how we can factor this quadratic. And again, its leading coefficient is not 1. And so that instantly there should be a cue that we are going to want to think a little bit more deeply about this one than just the standard straight-up sum and product rule. And so how this will work is we do want to play the sum and the product game again. Right? That same game that we played with trinomials that have a leading coefficient of 1, we're going to do the same thing here with one exception. When we play the sum and the product game, usually, so if we just had x squared, let's say minus 5x minus 6, or something like that. Maybe I'll do plus 5x minus 6. If we just had the standard without the leading coefficient in the front, then the product, we would cue in on this number, and we would place that number here. And the sum we would get from the coefficient in the linear term, the plus 5 over here. And we'd place that down here, right? That's how we play the standard sum and product game. And in that case, for this example, we would key in on positive 6 and negative 1 as having the required characteristics. But when that leading coefficient is no longer 1, when I introduce a 4 here, the good news is that the sum remains the same. So I'm still going to want the sum to be positive 5 in this example. What changes is the product. So my product that I'm going to put right here is no longer just negative 6, but it also incorporates the 4. So it takes those two together and it multiplies them. 4 times negative 6. And so the product that I want is actually negative 24. This is a method that's called the AC method. And it's called the AC method because you get that product by multiplying the coefficient of the quadratic term, which is often called A, multiplied by the constant term, which is often called C. So you multiply those two things together, and that gives you the target in your sum and product game. So now that we've reframed this, that's going to change our thinking about what pair of integers satisfy this sum and product game. So what two integers multiply together to give me negative 24, but also add together to give me positive 5? 8 and 3 are 5 units away from one another, such that when we give them opposite signs and add them together, their sum can be made to be positive 5. But if their product is negative, one of them's got to be negative. Which one should be negative?
8.
If I make the 8 negative, then the sum is negative 5. I want my sum to be positive 5, so I'm going to make the 3 negative. Okay. So 8 and negative 3 give us the pair that we want. So that's the first step in the process of factoring a trinomial with a leading coefficient that's not 1. So use A times C as the product in the sum and product game. So that was step 1. Now we've played that game and we've won. We find out that 8 and negative 3 do it for us. And so then the second thing we'll do is we'll put 8 and negative 3 put our answers on the grid in the first row and in the first column. How we use these answers, the 8 and the negative 3, is we're going to put them inside the table. We're going to make it 8x and negative 3x. Because what we find, what we discover when we play that game, is we discover how to break apart this middle plus 5x into a sum of two terms. So we really are kind of working backwards in a way. We know that in our grid, when we multiply things out, the like terms need to combine together to give me a positive 5x. And that's the thing that we satisfy first. We place those answers in the grid as the linear terms, as the terms with the x to the first power, as the linear terms. So to color code this for you when you look at it later at home, we did that here and we did that here. So that's how we used the answers that we got in the sum and product game. Okay, but now we also know that my quadratic and constant terms need to be those that came from our original expression, 4x squared and negative 6. So I'm going to put those in their places in the grid as well. And it's, again, pretty unambiguous where those end up coming from. So I'm just going to make a note of that as kind of step 3. Include other terms on the inside as well. So now we've filled out our grid, okay, on the inside. And we still have to work from the inside to the outside. That's what factoring looks like in one of these grids. But again, there are multiple ways of breaking apart each of the things that's inside the grid. Now, the 4x squared can be broken apart in 2 different ways, a 4x and a 1x, or a 2x and a 2x. The negative 6 can be broken apart in several different ways, right? Negative 6 and positive 1, negative 3 and positive 2, negative 2 and positive 3, negative 1 and positive 6, right? So there's a lot of possibilities. And I don't like possibilities. I like processes. So let's talk about my take on what the next step is. So here's how I do it. I take any row of this table. So maybe let's take the first row. And I want to find the greatest common factor of the terms in the first row. So here, if I highlight the terms in the first row, 4x squared and 8x, what is the greatest common factor between 4x squared and 8x? So the greatest common factor of 4x squared and 8x is 4x. And that starts my process. That's the nudge that starts our snowball rolling down the hill in this process, is we find out what is the greatest common factor, and we bring out that greatest common factor to the outside of the table. Once I bring that greatest common factor to the outside of the table, now I want to know what is its cofactor. What do I multiply 4x by to get the 2 terms in that first row? And so the next step is to factor the first row using the GCF. So we'll ask a question like, what do I multiply 4x by to get 4x squared? What's the missing factor here? X. How about 8x? What's the missing factor that connects 4x with 8x? 2. Right. So now I've set myself up to discover x plus 2 as one of the factors in my expression. All I have left to do now that I factored the first row is I just have one more missing coefficient right there. How do I find it? How do I know what belongs with the 4x on this first column? Well, what do I have to multiply x by to get negative 3x? 3, and a negative sign, yeah. So that's how we finish this process. That's, I guess, step number 6. Fill in last factor, last term. And verify that it actually works. When I put a negative 3 here, not only does x times negative 3 give me negative 3x, but also 2 times negative 3 gives me negative 6. So we did it. We got the factorization that we were looking for. And all we have to do now is just write our final answer. X plus 2 times 4x minus 3. So there's a lot of steps in this, but there's no point at which we were guessing and checking. There was no point where we had to be really sort of creative and look ahead and try and plan around contingencies. This, to me, is a method that, when applied with patience and care, will always work. It starts by playing the AC sum and product game. Multiply together the first and last coefficients, use that as the product that you're looking for, and then the sum is still the middle term, the middle coefficient. Then once you've played that game and gotten your winner, which in this case was 8 and negative 3, this is, I think, the step that people are most inclined to forget, is the step where we take those 2 answers and we split them into the 2 cells in our grid, the way that we did here. Right? We use those answers to split the middle term. But then once the middle term has been split, the rest of it, the factoring process, just goes from the inside of the grid to the outside. First by bringing out the greatest common factor of, you can do that with any row or any column of the table that you want to. I just picked the first row because it looked good to me. But you could have done the second row, you could have done the first column, you could have done the second column, it doesn't matter. All we need is one of the terms in one of the factors on the outside of the grid to get the process started. Because once we found the 4x, that instantly led us to the x plus 2 in the first row. And then with all of that in place, that led us to the final term, the negative 3. And then we were done.